Our next topic in section 3.1 on functions is finding the value of a function. So we just mentioned in the last video that we have y is equal to f of x. So in an equation we can replace y with the f of x and we have what's called function notation, f of x. So that's what we'll use here now to determine the value, evaluate functions. I'm sure you've probably done this before. Okay, so we are to find f of 3 given that f of x is this. All that means is everywhere we have an x in our function, we replace it with a 3 and then simplify as we can, right? So we have negative 3 times 3 squared plus 2 times 3. Negative 3 times 9 plus 6. Negative 3 times 9, negative 27 plus 6, or negative 21. So what that means is when your input is 3, your output is negative 21. If we wanted to generate ordered pairs, that would be the ordered pair 3, negative 21, right? Okay, that's all we're doing here. Now, that was where we put in a constant. In B, this is interesting, we're to find f of x plus f of 3. Well, f of x, they told us what that is. It's negative 3x squared plus 2x. And 3, f of 3, we just found that. It was negative 21. So this would be negative 3x squared plus 2x minus 21. And that's all I can do with that, right? Because I have substituted in a variable, so I'm not going to end up with a constant as my answer. I just have this expression. Likewise here, we're going to insert negative x. So negative 3 times negative x squared plus 2 times negative x. And all I can do here is simplify. What's negative x squared? Well, that just comes out to x squared, doesn't it? Because it'll be negative squared will be a positive. And minus 2x. And that's it. That's all I can do with that. All right, so this one we substituted in negative x. This time we're going to substitute in x and then apply the negative. These are different, okay? So this means the opposite of, what's f of x? Negative 3x squared plus 2x. So now I distribute that negative, and notice we do not get the same thing here, right? All right, finally, we're going to plug in x plus 3. Everywhere there's an x, now we plug in x plus 3. So it's squared there, plus 2 times x plus 3. All right, so that's negative 3 times, let's make sure we don't mess this up. X plus 3 squared means x plus 3 times x plus 3, and then you FOIL it. Distribute here to x plus 6. So I'm writing it out to make sure we don't forget that this is not x squared plus 9. I don't want to see that. Such a shame when people do that. Okay, it means write it twice and FOIL. X squared, then we'll have a 3x and another 3x for a total of 6, and then 3 times 3 is 9. Okay, then we'll distribute. We get negative 3x squared plus 18x minus, oh, not plus 18x, right? It's negative 3 times 6x minus 18x, negative 3 times 9 minus 27, plus 2x plus 6. All we have to do now is combine like terms. We have negative 3x squared is our only x squared term. I've got a minus 18x and a plus 2x, so that's minus 16x. And negative 27, excuse me, and positive 6 minus 21. Okay, so when we plug in x plus 3 in for x in our function, it simplifies to this. All right, now let's look at the domain, a little more information on domain of a function and how to find it, and then we'll look at some examples on how to find the domain of a function. The domain is the largest set of real numbers for which f of x is a real number. So it's all the numbers that give us real outputs, all the inputs that give us real outputs. In other words, the domain of a function is the largest set of real numbers that produce real outputs. start with the domain as the set of all real numbers. So we're going to be looking at an equation for a function, and we're going to start assuming it's all real numbers. Then, if the equation has a denominator, so we'll look to see, is there a denominator in this equation? Exclude any numbers that result in a zero denominator. Why? Why do we have to exclude any numbers that results in a zero denominator? Well, because that's undefined, right? If we have a zero in our denominator, that's undefined. So we can't do that. So any number that gives us an undefined condition, we have to take that out of the domain. We can't allow that to happen. All right. And that's only if we have a denominator with a variable in it, but we have to look and see. The other thing we'll look for, if the equation has a radical of even index, what does that mean? Square root, fourth root, sixth root, eighth root. I mean, we're not going to see those that high, but that's what we mean. Not cube root, not fifth root, even index. We'll exclude any numbers that cause the expression inside the radical to be negative, because we are looking for real numbers. This is all about real, not imaginary. So if we have a negative under the radical, we can't allow that to happen. So any value for x that makes that happen comes out of the domain. We won't be allowed to use it for our function. So why do we have to exclude these numbers? Because they are non-real. Okay, so these are the steps. If you can just remember these steps every time, finding the domain of a function is very simple. We'll start with all real numbers. If we don't have this and we don't have this, then hey, the domain is all real numbers, you see. So that's the idea. We start with this, look for these two conditions. Sometimes a problem will have this condition, sometimes it'll have this one, could have both, may not have either one. It's an analysis you do each time. So we'll do that in our next examples.